We often look up at the stars, exploring the distant universe, but today, we turn our eyes toward the planet beneath our feet, Earth. Did you know? From the moment you were born to the moment you're watching this video, Earth has already existed for about 4.6 billion years. And the entire history of humankind doesn't even make up 1/10,000th of that time. The planet we live on, the blue gem we call home, was nothing like what we know today. There were no oceans, no blue skies, and certainly no life. In its earliest days, Earth was a complete, suffocating hellscape. Today, we will board a ship of time and travel back 4.6 billion years, crossing the long darkness before humanity ever appeared, to witness the most primitive, the most violent, and the most crucial epic chapters of our planet's evolution. In the moments ahead, you'll see how Earth transformed from a scorching sphere of molten rock into a miracle capable of nurturing life. If the mysteries hidden deep within our planet fascinate you, be sure to watch until the end. Are you ready? Let's begin this 4.6 billion year journey through time. Our story begins about 4.6 billion years ago. In a primordial nebula of the early solar system, matter began to collapse under the force of gravity, giving birth to our blazing Sunday. The remaining dust and gas started to collide and gather together. This era is known as Earth's accretion period. Countless planetesimals and asteroids, like cosmic building blocks, violently crashed into one another, stacking layer upon layer, until they ultimately formed the earliest version of our planet. In the early stages of Earth's formation, a destiny-shaping event occurred, the giant impact. A primordial planet roughly the size of Mars, known as Theia, collided with Earth at an astonishing speed and angle. The energy released by this impact was unimaginable. It nearly melted the entire planet and blasted vast amounts of crust and mantle material into space. These ejected fragments, drawn together by Earth's gravity, eventually formed the companion we know so well in our night sky, the Moon. Ironically, it was this catastrophic collision that stabilized Earth's axial tilt and created the tides, laying the groundwork for the evolution of life that would come millions of years later. Imagine the scene. Earth's surface was covered by a thick, blistering ocean of molten rock. Temperatures soared to several thousand degrees Celsius, leaving no solid ground anywhere. The sky was shrouded in dense gases spewed out by relentless volcanic activity, filling the air with methane, ammonia, carbon dioxide, and other toxic compounds. Inside the planet, the decay of radioactive elements generated immense heat, while outside, asteroids and comets continued to bombard Earth without pause, keeping the entire world in a constant state of high fever. Scientists believe that even when a primitive crust finally began to form as the planet cooled, it was repeatedly melted again by massive impacts. During this era, Earth was nothing less than a true inferno. As time passed, the radioactive materials deep within Earth gradually diminished, and the frequency of massive impacts began to decline. The ocean of molten lava on Earth's surface slowly cooled, forming the earliest thin and fragile primordial crust. Yet the planet was still wrapped in a thick atmosphere rich in water vapor, carbon dioxide, and nitrogen, like an enormous greenhouse that trapped heat tightly within. To form oceans, Earth first needed water, and scientists proposed two primary sources: deliveries from comets and asteroids. Many of the bodies that struck Earth contained abundant ice, acting like cosmic water carriers, delivering frozen cargo to the young planet. Water vapor from volcanic eruptions. Water trapped inside Earth escaped into the atmosphere as vapor through relentless volcanic activity. When Earth's surface temperature finally dropped below the boiling point, the enormous amount of water vapor began to condense. Torrential rains fell for millions of years. Imagine how relentless and overwhelming that rain was. It fell onto the scorching crust, evaporated instantly, condensed again, and fell once more. After countless cycles, the water gathered in low-lying basins, forming Earth's oldest and most precious treasure, the primordial oceans. The appearance of the primordial oceans marked the beginning of the Archean Aeon, a time of ancient life and increasing planetary calm. Beneath the oceans, enormous geological forces stirred. Convection in the mantle pushed fragments of the early crust, giving rise to the first hints of plate tectonics. Small continental cores began to appear, becoming the seeds of the vast continents of the future. These earliest land masses were tiny, likely volcanic island chains floating in the global ocean. Earth was no longer a chaotic inferno. It began to reveal a vibrant, blue character. But even with oceans and land, life had not yet emerged. This is the most fascinating chapter. How did life begin? Scientists believe life likely emerged in the primordial oceans or near hydrothermal vents on the seafloor. The early ocean, sometimes called the primordial soup, was rich in dissolved chemicals. Driven by volcanic heat, lightning, and ultraviolet radiation, simple inorganic molecules underwent complex chemical reactions, forming essential building blocks of life: amino acids, nucleotides, and other organic molecules. Over time, these molecules assembled into proteins and nucleic acids, eventually giving rise to the first primitive cells capable of self-replication and metabolism. Around 3.5 billion years ago, the first microorganisms, mainly anaerobic single-celled life, appeared. They required no oxygen and fed on chemical compounds in the ocean. They are the common ancestors of all life on Earth. Among these early life forms emerged a world-changing organism, cyanobacteria, also known as blue-green algae. Cyanobacteria possessed a revolutionary ability: photosynthesis. They absorbed sunlight, carbon dioxide, and water, and released oxygen as a waste product. For hundreds of millions of years, these tiny organisms spread through the oceans, releasing oxygen continuously. At first, this oxygen reacted with dissolved iron in the ocean, forming giant banded iron deposits. Around 2.4 billion years ago, after the iron in the oceans was fully oxidized, excess oxygen began spilling into the atmosphere. For the anaerobic life forms of the time, oxygen was deadly poison. A massive extinction followed, the first major biological catastrophe on Earth. Yet this disaster paved the way for complex life. The accumulation of oxygen in the atmosphere formed the ozone layer, shielding Earth from lethal ultraviolet radiation. It also enabled some organisms to develop efficient oxygen-based respiration, creating the energy foundation needed for multicellular life, and eventually, for us. Around 720 million years ago, rising oxygen levels disrupted Earth's greenhouse balance. As atmospheric carbon dioxide decreased, global temperatures plummeted, triggering the most extreme glaciation in geological history, the Snowball Earth events. Imagine the entire planet, from poles to equator, encased in ice up to a kilometer thick, shining like a frozen white marble in space. The ice reflected sunlight, worsening the cooling in a vicious cycle. Life survived only in deep-sea vents or small patches of unfrozen water. How did Earth thaw? The answer: volcanoes. Beneath the frozen surface, plate tectonics and volcanic activity continued. Volcanoes released carbon dioxide that became trapped under the ice. After millions of years, enough CO2 accumulated to trigger an intense greenhouse effect, melting the global ice and causing catastrophic floods and environmental upheaval. The thawing of Snowball Earth released immense nutrients into the oceans, setting the stage for a resurgence of life. During this era arose the Ediacaran biota, the first large, multicellular organisms. Most were flat, soft-bodied creatures resembling mattresses or leaves, living in shallow seas. They were Earth's earliest large-scale life forms. As Earth's environment stabilized and oxygen levels rose further, the greatest biological turning point in history arrived: the Cambrian explosion. In just tens of millions of years, an instant in geological time, almost all modern animal phyla appeared in the fossil record, including the ancestors of vertebrates. Animals evolved shells, skeletons, eyes, and complex organs. It was an age of biological fireworks, filled with creatures like trilobites and anomalocaridids roaming the seas. With this explosion of diversity, Earth entered the Phanerozoic Eon, a new era of competition, cooperation, and innovation. Life would soon move onto land, ultimately paving the way for the rise of humans. This immense pre-human history teaches us that Earth is not fixed or eternal. Its evolution is shaped by both violent extremes and delicate balances. Every seemingly catastrophic event, whether the giant impact or the great oxygenation, became a catalyst for life to advance to a higher stage. The land beneath our feet, the air we breathe, and the oceans we see are miracles shaped by billions of years of geological, chemical, and biological interplay. Humanity is merely the latest chapter in this long and extraordinary story. Which stage of Earth's history fascinates you the most? The fiery inferno of the Hadean, or the photosynthetic revolution of the Archean? Tell me in the comments. If you enjoyed today's cosmic journey, don't forget to like, subscribe, and turn on the notification bell so you won't miss our next episode. Thanks for watching. See you next time.